Data types in C. Data type in a programming language determines the type of data it deals with. That is, it determines the type of operations that can be performed on the data. All variables, arrays, functions, etc. must be declared as one of the data types that we discuss in this section. The data type classification is primary data types, derived data types, and user-defined data types. Primary data types are integer, character, floating point, Boolean, and void. Derived data types are array, pointer, and function. User-defined data types are structure, union, enumerated, and typedef. Primary data types. Integer data type. Integer data type hold integer numbers. The keyword is int. An example is int num, where the variable num is declared as an integer data type. %d is a format specifier to scan and print values using the scanf and printf functions. The memory size is 4 byte. The value range is from minus 2 raised to 32 to 2 raised to 32 minus 1, including the 0. That means it can take 2 raised to 32 values. That depends on the number of bytes it takes to store in a memory location, that is 4 bytes or 32 bits. Example values are here: 10, 35, 0, minus 102, minus 900. The other variants of integer data type are short int or simply short. Short int takes only 2 bytes to store in the memory. Unsigned short is the unsigned version of short int. The format specifier is %hu. This also takes 2 bytes. Here there will not be any negative numbers, only positive numbers including 0 can be used. That is, the range is from 0 to 2 raised to 16 minus 1. As it is taking 2 bytes, it is 2 raised to 16 minus 1. 0 to 2 raised to 16 minus 1. Next is int or signed int. Both have the same meaning. %d is the format specifier. This takes a minimum of 2 bytes and usually it takes 4 bytes. That is, it is compiler dependent. The number of memory locations it depends on the compiler. But most common compilers use 4 bytes. Unsigned int. This is the unsigned version of int with format specifier %u, and it takes 4 bytes and minimum 2 bytes. Long int or long, percentage specifier is %li. 8 bytes are taken. That's the minimum value and the common value too. Long int, %lli is the format specifier. This also takes 8 bytes minimum. This is an example to show the usage of integer data type. Here the variable num is declared as integer type and initialized to a value 10. We can use the size of operator to find out the size of different types of integers. So first, size of short int, that is equal to 2 bytes. Then size of unsigned short int, also 2 bytes. Size of int, 4 bytes. Size of unsigned int, also 4 bytes. Size of long int and size of long int, 8 bytes each. To find out the value of this num, we can use the format specifier %d. So here the value of integer variable num equal to 10 is printed. We can also find out the size of the variable using the variable name. That is, size of num will actually print the size of int. The data type, it is declared as integer data type, so size of num will return 4 bytes. Character data type. These are used to hold characters. Only one character can be used to store in a character variable. The keyword is char. An example is char ch. Here the variable ch is declared as character data type. %c is a format specifier and it takes only 1 byte to store in the memory. It can take a value range from minus 2 raised to 8 to 2 raised to 8 minus 1, that is from minus 128 to 127. That is a total of 2 raised to 8 number of values. Example of values are D, Y, 5. These three are given in chords. That means these are characters. And we can also store the numbers like 9, 32, minus 27 to a char data type, because char is actually the basic version of integer data type. That is an integer data type with a storage capacity of only 1 byte is the character data type. When we store the characters in a char variable, it is given within single quotes and the corresponding ASCII value is actually stored in it. We can also store an integer as in the example without the quotes. So if we store the integers, we have to give without quotes. %c format specifier can be used to print the character and %d to print the corresponding ASCII value. If we store the integer numbers directly like this 9, 32, 27, it is actually the ASCII number stored in the variable. And if we try to print it using the %c format specifier, the corresponding character will be printed. That means if we store this 9, this is taken as the ASCII value of the character corresponding to the ASCII value 9. The variants are char or signed char, both are same. Format specifiers of signed and unsigned char are %c itself and both takes 1 byte. The value range of unsigned char is from 0 to 255. Example of the character data type. Two characters are declared, char ch is equal to d within quotes, and another number is stored in the character variable n, that is 69 is stored in character variable n. So we shall see how the different values are printed using %c and %d. First we print the size of the char and unsigned char using the size of function. So both will print 1 byte as both takes 1 byte. Then printing the value of character variable ch using %c. It will print the value d. The value d will be printed in this line. Next we are going to print the ASCII value corresponding to ch using %d as the format specifier. Now the ch value, it will print 100. 100 is a corresponding ASCII value of letter d, small letter d. Next, the size of character variable ch is calculated using the size of operator and it is equal to 1 byte. Next we are going to print the value of the character variable n using %c. If we print using %c, it will print the corresponding character. So the value that we have stored is actually the ASCII value corresponding to capital letter E. So when we try to print using %c as a format specifier, it will print the corresponding character value. Next, to display the integer value that is stored or the corresponding ASCII value that we have stored, we can use the %d format specifier. Now it will directly print the value that we have stored, which is equal to 69. This value will be printed. Next, the size of the character variable using %ld and the size of operator will return 1 byte. So all the character variables will take only 1 byte for storage. Floating point data type. Floating point data types are used for storing real numbers. Keyword to use is float. An example is float var. Here the variable var is declared as floating point type. The format specifier is %f and it takes 4 bytes for storage in the memory. The value range is from -3.4 into 10 raised to 38 to 3.4 into 10 raised to 38 with 6 decimal place precision. Example values are 3.5 plus 512.4543 minus 86.784, and these are all decimal form and it can be printed or scanned using %f as the format specifier. The corresponding exponential form also can be written. This is one of the example, 8.964578 e plus 02. It can be printed or scanned using %e as the format specifier. The variants of floating point types are float, %f 4 bytes, double, %lf 8 bytes, and long double, %lf, here L is capital, 16 bytes. An example of usage of floating point data type. A variable num is declared as float and initialized to the value 53.2915. Size of float is printed using the size of operator. So size of float will return 4 bytes. Size of double will return 8 bytes. And size of long double is 16 bytes. Now we are going to print the value of the floating point variable num using the format specifier %f. So the value will be equal to 53.291500. That is, it will be printed with 6 decimal places. And if you want to limit to some other values, some other value of decimal places, we can write like this. That is, value of num limited to 2 decimal places. For that, within this %f, we can fix 0.2. 0.2 stands for limit to 2 decimal places. If you want to limit to 3 decimal places, we can write 0.3. And if you want to limit to 4 decimal places, 0.4, like that. So now the result is 53.29. So 0.2 within this %f will limit the decimal places to 2. Size of the floating point variable num, it is 4 bytes. Boolean data type. This type is used for holding Boolean values, that is 1 or 0, to represent true or false conditions. 1 stands for true and 0 for false. The keyword to use is bool. Example of declaration is bool b. Here the variable b is declared as Boolean data type. It can take only two values, that is 0 or 1. So an example is 0 or 1. Format specifier is %d itself to print the Boolean values. It takes 1 byte to store the data in memory, but actually it utilizes only 1 bit. The value range is 0 to 1. It's only two values, 0 and 1. Before using the Boolean data type, we have to include the library stdbool.h, in which the definition of Boolean data type is written. Next is void data type. This data type represents no value. Actually, it is used for declaring functions having no return value. The keyword to use is void. Example of Boolean data type. The variable s is declared as bool type and initialized to the value 1. So we have to include here the stdbool.h library. Printing the size of bool. So it will print 1 byte. The value of bool variable printed with the help of format specifier %d, it is 1. The value 1 is printed here. The void data type. To represent the function of void data type, I am using a function printsum, which is called from the main function. And here you can see the main function is also of void type. That means the main function will not return anything to the operating system. That return nothing to the operating system. Here it is declared two values, a is equal to 5 and b is equal to 10 as integer type, and calling the function printsum of a comma b. So two integer values are passed to the function. So this function is void type, that is it is returning nothing to the called function. It takes the two values of a and b and prints the sum of a and b like this. 5 plus 10 is equal to 15. So here no values are passed back to the main function. Nothing is actually returned back to the main function. That's why it is void type. Derived data types. Arrays, pointers and functions. Arrays. These are used for storing a set of elements of the same data type. It can be a single dimensional or multi-dimensional. Keyword used is that of the basic data type, which is used for making the array. Example is int AR of 10. Here AR is the array name, 10 is the number of elements, the maximum number of elements AR can hold, and int is the type of the array. That means AR of 10 can hold 10 elements of integer data type. Pointers. These are used for storing address of a memory location. The operator star is used to make a variable of pointer type. Example is int star ptr. Here star ptr will make ptr a pointer type variable which points to an integer type data. Functions. A function is a set of code that performs some specific task or a set of tasks. Example is int sum, int a, int b. Here the function name is sum, which takes two arguments a and b of integer data type, and it can return an integer data back to the function from which this function is called. For detailed explanation of arrays, pointers and functions, you can click on the corresponding video links that are given in the description box below. User-defined data types: structures, unions, enumerated and typedef. Structures. These are used to make a collection of variables of same or different data types. Keyword is struct. In the example, two members, book name of 25, which is a character array, and year, which is an integer data type, are made members of struct library, which is the structure, and the variable book is declared as struct library type having these two members. So after declaration, the variable book will have two members, book name and year. So we can access these elements just by using the dot operator. That is, the first element book name can be accessed like book dot book name. The second element is book dot year. Unions. These are used to make a collection of variables of same or different data types, similar to that of structures. But in the case of union, only one member of a union can contain a value at a time. Keyword is union. The example is similar to that of structures. A union library is made with two members, a character array and an integer value, and book is declared as union library type with these two members. For detailed explanation of unions and structures, you can click on the corresponding video links below. Enumerated data type. This data type can be used to assign names to constants. It just increases the readability of our code. Keyword is enum. The syntax is like this: enum, enum name, within curly brackets member 1, member 2, etc. up to member n. The enum name is the name of enumeration having members member 1, member 2, etc. Here an example is given: enum trimester July, August, September, October. July, August, September, October are the members of enumerated type trimester. By default, the value of first member is 0, second member is 1, third member is 2, etc. That is, in this example, by default, July equal to 0, August equal to 1, September equal to 2, October is equal to 3. We can also provide alternate values inside the definition like enum trimester of July equal to 1, August equal to 2, September is equal to 3, October is equal to 4. Declaration. To declare a variable as enum trimester type, the following can be written: enum trimester t. Here t is declared as the enum trimester type, and it can hold any values July, August, September or October. An example to show the usage of enumerated data type. The same example is taken enum trimester of July, August, September and October. One more example is taken to give user-defined values to the different members of the enumerated data type. Enum colors of red equal to 10, blue is equal to 5, green is equal to 7. Here, if we do not give these values 10, 5 and 7, the default value will be red equal to 0, blue equal to 1 and green is equal to 2. Now these two variables are declared. T is declared as enum trimester type. C is declared as enum colors type. That means T can have any value from July to October and C can have any value from red to green. Now I am assigning two values, T is equal to September and C is equal to green. And if I try to print the value of T and C, I can use the %d format specifier for printing, and this will print T equal to 2 and C equal to 7. T is equal to 2, that corresponds to September. 0, 1, 2. September is equal to 2. C for green, the green value is 7 here. So C is equal to 7. Typedef. This is used to give a new name to an existing data type. The keyword is typedef. Syntax: typedef data type new name. Data type is the existing data type name and new name is the new name given to it. Example: typedef unsigned int positive. Here the existing data type is unsigned int and the new name given to it is positive. A new name positive is given to the existing data type unsigned int. Now we can declare a variable x as unsigned int by typing positive x instead of unsigned int x. This is an example. Typedef unsigned int positive and declaring x as positive type. Assigning a value x is equal to 100 and printing the value and size of x. Value of x is equal to 100 and size of x, if we print, it will be that of the data type. The data type is unsigned int, so the size is equal to 4. Thank you.